Hello again, dear students. I'm going to finish our uh, subjects 3.4. So going to talk about derivative of the ln and derivative of the exponential. So natural logarithm is that ln, and later we have a log, and later we will have a exponential. So first of all, if you have a ln, for example, y is equal to ln of x, the derivative will be 1 over x. Okay, so if you have y is equal to ln of, for example, 5x, the derivative will be 1 of 5x, but do not forget about multiply also inside. We have a 5. Okay, so again you'll get 1 over 5x. And if you have y is equal to 1 over, for example, y is equal to ln of 5x squared minus 2x and plus 3, the derivative will be 1 over all here, 5x squared plus 2x plus 3, then multiplied to inside, is equal to 10x plus 2. So that's how to multiply by the derivative of the inside. Now you can see the another more example in page 1 for more information. Okay, dear, that's all that you need to look at it. In the second page we have a money. If in case you have something like that and you want to find the derivative, so now here you know the benefit of the ln. How? Because if you want to, for example, you have y is equal to x squared plus 1, x plus 3, 1 over 2, x minus 1 when x greater than 1. You want to, in case you want to find the derivative of something like that, you need many works. Why? Because here's the x1 squared, x minus 1, multiply derivative of here. Look at this derivative as two functions. I need many steps, more steps than it's not one step. You need more steps, several steps, and then the second, then multiply by 1. So you need a lot of things and a lot of steps. But in case if you can use the ln, you can directly say y is equal to x squared plus 1, x plus 3, 1 over 2, x minus 1. So in case if you want to use the ln to both sides, you can see the ln will summarize or minimize our work quickly. Why? Because we are going to use the properties of the ln, and these properties will be more helpful for us. For example, you know ln of a over b is equal to ln a minus ln b. So in that case I will get ln of numerator x squared plus 1 x plus 3 1 over 2 minus ln of denominator and also I know the ln of ab multiplication will be ln a plus ln b. Okay, so in that case if we have a multiplication, we can change it to what? We can change it to the addition. So plus ln of 3 plus plus 3 1 over 2 minus ln of x minus 1. And also I know the ln of an will be n ln a. The power directly can decrease, can be raised down to here. So that in that case I know this 1 over 2 also can come to the down plus 1 over 2 ln of x plus 3 minus ln of x minus 1. In all these cases, if you want to find the derivative, I know this is an implicit function because I have a y. So in that case I say 1 over y prime. Okay, do not forget about y prime. Why? Because I'm going to find the derivative of both sides. So 1 over y prime. How about here? 1 over x squared plus 1 multiplied by 2x. Why? Because inside. How about here? 1 over x plus 3. How about here? 1 over x minus 1. That's all. And you can use the rest properties like here. So in that case we have this derivative and that one, and the other side is implicit function. Do not forget about the implicit function, saying in that case we have y prime. You can write y prime is 1 over y. We're going to up and I'll get y. Where is y? Here is y. You can use here. Here's y that we have before, and here's the derivative of it. So you get the result as soon as faster than the old version of the derivative. That's why I say the benefit of the len will give us the more work. Let us find the derivative more faster than the other side. Now in the page number 3 we are going to talk about exponential function. When I say exponential function, you know we have a e to power x, and the derivative of e to power x, as you saw this one in your high school, they cannot change. Even the second derivative, the third one, and it still remains. But in case you have, for example, y e to power minus x, you want to find the derivative, do not forget about the derivative of the hat. So in general, if you have eu is equal to what? U prime is equal to itself multiply u prime, the hat, multiply the hat, not all. For example, I have y equal to e to power minus x, so I say y derivative is equal to itself, and how about derivative here is equal to minus 1. So that's also it's equal to minus e to power minus x. Okay, dear? Y is equal to, for example, e to power sine of x. So I am going to say the derivative of this function is itself sine of x, multiply here is equal to cosine of x. Okay, dear? That's all I need to mention it here, and go try to solve. I solved this one for you. Try to solve the d by yourself, and c is equal to itself derivative of the hat, and the derivative of the hat is equal to like that. How about if I have this in the natural exponential? In case I have e to power y is equal to au, so I'm going to say that e to power au directly. The page for that you have is equal to au, okay, y prime is equal ln of the base. For example, you have y is equal to 3 to power x, okay, not e to power x, 3 to power x here. It's a logarithm. So in that case y prime will be itself, okay. Do not forget about the ln of base, ln of the 3. So that's all that you need to know. How about in case, for example, if I have y is equal to sine of x, so y prime will be what? Itself 3 to the power sine of x multiplied sine is equal to cosine of x. Okay, so that's all that you need to know about. Sorry, and ln of base, ln of 3. Do not forget about ln of 3. Okay, dear. That's all. There's no difference between e and a. Really, just we have a more addition ln of the base. How about if I have, for example, log of ab or au function? So directly you can say is equal to 1 over ln a, 1 over u prime. What do you mean by that? What do you mean by that? For example, y is equal to log of 2 for say x. Directly I can directly say ln of 2 with the base 1 over x, and there's nothing else. How about another example? If I have a log of x squared plus 5x over 3, I can say directly y prime is equal to 1 over ln 3, okay, 1 over like a log, like a ln, so 5x multiply what? Multiply 2x plus 5. This is inside and outside here. So what's the difference between derivative of ln and log? Just we have what? We have 1 over 3. Now I'm summarizing this lecture. I say if you have y is equal to ln u, directly you can say y prime is equal to 1 over u prime, okay, derivative of u. The second, if you have a log, direct you can say is equal to the same as here, but just 1 over ln of the base. Okay, and for the exponential in general, if you have a u, you can say y prime is equal to itself u prime. In case you have a number, you can say directly is equal to au ln of a u prime, or you can say ln of a. Let be like that, it's more to be more sufficient or more similar to the rules. So you can summarize your work, and here's a Labbani example, more than extra example for you. You can see I solved this one for you. You can see how to deal with that derivatives. Okay, dear, this is about 3.4. we finished here, and it's not difficult. I'm going to the next section, 3.5. That's talking about what do you say, I'm talking about how to find the derivative of the hyperbolic function. I'm just going to memorizing you, if y is equal to sine of x, then y prime is equal to cosine of x. I just for memorizing, y is equal to cosine of x, then y prime is equal to what? To minus sine of x. Okay, so number 3, if y is equal to tan of x, then y prime is equal to secant square of x. Number 4, y is equal to cotan of x, then y prime will be minus cosecant square of x. I'm going to write like that. Okay, number 5, if y is equal to sine secant of x, okay, then y prime will be secant tan of x. Number 6, cosecant of x, y prime is equal to cosecant cotan of x, and do not forget about minus here. Why I wrote this one for you, to just to remember these again, because in the 3.5 we have what? We have hyperbolic derivatives, so it's equal to y equal to sinh of x, then y prime is equal to what? Y is equal to cos of x, so y prime is equal to what? Y is equal to tan hyperbolic of x. Okay, just we have a rule, okay, nothing else. Number 4, y equal to cotan hyperbolic of x, so y equal to cosecant hyperbolic of x, y equal to finally cosecant hyperbolic of x, then y prime. Look at the difference. The 3, 1, they are the same. So sine is equal to cosine. So here sine hyperbolic is cosine hyperbolic. So sine hyperbolic. So secant hyperbolic square. Cosecant hyperbolic square. Secant hyperbolic of x, tan hyperbolic of x. Cosecant hyperbolic of x, cotan hyperbolic. Well, as a function, they are the same. As a function, there is no difference. So don't say, oh, I have a many rules. No, you have no many rules. They are the same. But there's the same difference from here, from after the tan, we have what? We have a negative sign here. So in the sine trigonometric functions and hyper, we have the events are negative, but in the hyperbolic, the third part are positive, the others are negative. How about example on it? For example, you have y is equal to tan hyperbolic of 1 plus x square. So find the y prime. So y prime, I am going to say y prime is tan is equal to secant hyperbolic square of x. Here's x. Now, because I have a bracket parenthesis, I'm not going to forget about, I'm not forgetting about how to find the derivative of here. So is equal to what? 1 over 2, right, itself 2x. How I do that? Try to do it by yourself because you need more work. So this one is equal to y prime equal to 1 over 2. 1 over 2 is going to just, it remains 1 plus x square multiplied by second hyperbolic square of this angle. Okay, dear, that's all that you need to find or to know about derivative hyperbolic. The rest one are the just rules, and use the same strategies that we have before. I taught you to find the derivative of the angle and the derivative of inside and outside the function. Now in the next video I'm going to talk about 3.6 and 7, which are derivative of the inverse of trigonometric functions. Thus they are very important for you, and they are not a lot, that's a little bit rules. Thank you for watching. This video was about 3.4 and 3.5. Please do not forget how to summarize the rules here, because we have many rules. You just try to summarize them, write on the paper, then later try to use them one by one occasionally. Thank you for watching.